Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2018 again, time zone 0 in November. Question number 22, something to do with topic 7, equilibrium concept, a really abstract topic in the physical chemistry area. Let's see, consider the following reaction. So with N2O in equilibrium with nitrogen gas and oxygen gas, given the values of the equilibrium constants Kc under different temperatures are shown. So what you should see obviously is not anything about specific numbers, but it's a trend. This is a very important trend that, as you can see, when the temperature in Kelvin increases, the Kc value also increases. So here is the most important conclusion. Temperature increases, in this case, the Kc increases, right? Yeah, what temperature increases implies, according to the Le-Chatelier's principle, when temperature increases, the system will try to favor more of the endothermic reaction, right? Endothermic reaction. Promote. M-O-T-E, right? So this is what we conclude from the Le-Chatelier's principle, right? And with this perspective, Kc increases. And as we have learned, Kc is equivalent to a ratio of product concentration over reactant concentration, right? Which means if this value is increasing, what we are going to do is to increase the denominator, or on the other side, decrease the denominator, right? So another perspective, that one more round of deduction, is that the right hand side is being promoted, right? Or I can say favor more about the right hand side. So the conclusion is, for this case, Kc increases, the right hand side is being promoted. So what we can conclude from this perspective is that the forward reaction, so right hand side, right? The forward reaction is going to be endothermic, right? So that's why forward, F-O-R-W-A-R-D, will be endothermic, right? So this is a really important conclusion that most of the questions are now asking in such a way that wanting the students to understand how we can derive to the endothermic or exothermic nature of the forward and backward reaction. Important. Let's see, right? So let's see which statement is correct. So this time asking for correct statement at higher temperature. So meaning that when temperature increases, which statement will still stay the same or stay correct? Let's see. For A, the forward reaction is being favored, as we kind of already conclude, right? Under higher temperature, the Kc increases. Kc increases implies the right hand side reaction is more promoting, and so that means forward. Easy. So we killed the question already for A, but let's double check. For B, reverse reaction is favored. Obviously, this is an opposite statement. Obviously not correct, right? C, the rate of reverse reaction is greater than that of the rate of the forward reaction. This is obviously wrong, right? Why? Because under high temperature, true that both the forward and backward reaction will be favored. This is important. But the thing is, we conclude that the right hand side is more promoted. So which means the forward reaction should be faster than the backward reaction. So that's why reverse greater than forward, that is obviously wrong. In fact, it should be forward greater than the reverse. Now, in terms of the rate, so the forward rate will still be greater than the backward rate. But remember, both having a promotion, because temperature increases, rate increases for both sides. But just the forward promotes even more in a greater extent. So that's why still the forward rate should be faster than the backward rate. Important, right? So that's why C wrong. D is kind of actually not possible. The concentration of both reactants and product increases. This is not possible under changing temperature, because temperature won't change anything about volume, right? So that's why in this case we assume every other factor stay constant, or the concentration will not be changing at the very first beginning. And also, but then, even after there's a change, we know that forward is being promoted, so we can only conclude that more of the product, but less of the reactant. So you can't say the reactant is going to be increased as well for the concentration, so it doesn't make sense. So that's why for the reactant to having an increased concentration, wrong. So that's why obviously the answer going to be A.